Good day, everyone. Welcome to our Mathematics 10 First Quarter Module 1 Lesson 2 entitled Generating Patterns, or known to be the sequence. For our task for today, we need to learn how to generate patterns. Specifically, we need to analyze patterns and relationships, generate patterns, and formulate a rule or equation based on the given sequence. Are you ready? Let's now start learning mathematics. Let us always remember that the patterns play an important role in sequence. For our first task for today, given a fixed rule, we need to identify terms. For example, given that fixed rule a sub n is equal to 4n minus 1, let us identify the first three terms. Again, what does first three terms mean? Can you still remember? Very good. Once we say first three terms, we need to identify the values of a sub 1, which is our first term, a sub 2, the second term, until a sub 3, the third term. So it only means that the values of n are 1, 2, and 3. Is that clear? Okay, let's proceed. Let's start solving. For the first term, that gives us the value of n, which is 1. So we need to substitute n is equal to 1 on the given rule. That gives us a sub 1 is equal to 4 times 1 minus 1. And then, simplify the things that we can. 4 times 1, that is 4. Then, 4 minus 1, that gives us 3, which is the first term. So take note of that. Then, let's now have n is equal to 2 because that is for the second term. Let's just follow the same process. So n will become 2. So a sub 2 is equal to 4 times 2 minus 1. Then simplify again. 4 times 2, that gives us 8. Then minus 1. So our second term is 7. Is that clear? Very good. Now, it's your turn. Try solving the third term, which is a sub 3, where n is equal to 3. You can do it. Are you done? Let's compare our answers. So let us always start with our fixed rule or the pattern, which is a sub n is equal to 4n minus 1. Substitute n is equal to 3. So that gives us a sub 3 is equal to 4 times 3 minus 1. Then simplifying 4 times 3, that gives us 12. Then minus 1. Our third term now is 11. Is that clear? So recalling again, we need to write all the terms in proper sequence. So our final answer, given that a sub n is equal to 4n minus 1, the first three terms are 3, 7, 11. So make it sure that it is in proper order. Is that clear? Okay, very good. Let's try another one. Determine the first four terms of a sub n is equal to n squared plus n. So, if we are asked to find the first four terms, what are the values of n? Correct. The values of n are 1, 2, 3, and 4. It is only until 4 because we are looking for the first four terms. Let's proceed on solving. Let's have the first term. So a sub n is equal to n squared plus n. What will be the value of n again for the first term? Okay, good. So we need to substitute n is equal to 1. We will have a sub 1 is equal to 1 squared plus 1. Okay? And then substitute. After substituting, we need to simplify. So we will have 1 squared, which is 1, then 1 plus 1. That gives us 2 as the first term. Then take note of that again. Then let's proceed on the second term. We will have a sub n is equal to n squared plus n as our fixed pattern. So right now, we will substitute n is equal to 2. So we will have a sub 2 is equal to 2 squared plus 2. Then simplifying 2 squared, we will have 4 plus 2. Then 4 plus 2, that is 6. That is our second term. Okay, for the third term, we will have n is equal to 3. So a sub 3 is equal to 3 squared plus 3. Then simplifying 3 squared, we will have 9. Then add 3. The answer here is 12 as the third term. Then lastly, for the fourth term, we will have n is equal to 4, where a sub 4 is equal to 4 squared plus 4. We need to simplify 4 squared, which is 16. Very good. So then add 4, we will have 20 as our fourth term. So we need to write our answers in proper order. We will now have the first 4 terms of a sub n is 2, 6, 12, and 20. Is that clear? Okay, very good, my dear students. So what if the question is looking for a specific term? What are we going to do now? So let's have an example. Find the fifth term of this a sub n is equal to 3n squared over n minus 2. So again, having the keywords, the fifth term, what must be the value of n? Very good. N will become 5 because we are looking for the fifth term. So following the process like we did a while ago, but take note, we only need to get the fifth term. It doesn't say first 5 terms, okay? So we need to substitute n is equal to 5 because we're only looking for the fifth term. So replace all n by 5. You will have a sub 5 is equal to 3 times the square of 5 over 5 minus 2. Then simplifying 5 squared and 5 minus 2. 5 squared, we will have that is 5 times 5. We will have 25. And then 5 minus 2, that is 3. Then what can you notice about this part of the solution? Can we simplify it easier? Okay. We need to cancel 3 because that gives us 1, which is 3 divided by 3, that is 1. So with that, we will have a sub 5 is equal to 25. And that is our fifth term. Okay? So for our second task, given the terms of a sequence, we need to generate a pattern. So this time, let's have the other way around. So going back to our first example, let's have a sub n is equal to 4n minus 1. Can you still remember that? Having the first 3 terms of 3, 7, and 11. So our goal right now is the general pattern. Okay? So we need to generate this general pattern given a sequence or given the terms of a sequence. So let's proceed. Given 3, 7, 11, determine the general pattern or known to be a sub n. We can solve this using 2 methods. But from these methods, we need to learn how to get the common difference between 2 consecutive terms. So if there is an operation involved, once we say difference, the operation involved is subtraction. Very good. So let's learn that first. So having 3, 7, and 11, so we need to get the common difference. Subtract the two consecutive terms from right going to your left. So let's have 3 and 7. We will now have 7 minus 3, that is 4. And then 11 minus 7, that is also 4. That gives us the common difference having a symbol of small letter d, which is 4. So we can only proceed on these two methods if and only if we have a common difference. So if not, we cannot proceed on the process. So take note of that. So let's now start our first method, okay, which is by inspection. So given the sequence 3, 7, 11, getting again the first common difference, subtracting from right to left of the two consecutive terms, we will now have 4 as our first common difference. So going back to our grade 9 topic, once we have the first common difference, we are talking about a linear equation. Okay? So it only means that we are expecting a general pattern which is in linear form. So what are we going to do? So it only means that we will have, or we are expecting of a sub n is equal to 4 times n. But let us try. A sub n is equal to 4n, where n is equal to 1. So let us try getting the first term. So our goal is to get 3. So we need to substitute. So a sub n will become a sub 1, then 4n will become 4 times 1. So simplifying it, our first term that we get on our initial guess of a pattern, we will have only 4. But the first term is 3. So we are getting an incorrect answer or an incorrect pattern. So think of a way that we need to get 3. So how come that 4 will become 3? So that is our goal. What do you think? How come that 4 will become 3? Can you think of it? Okay, so it only means that we need to subtract 1. So, yun ang kulang doon sa a sub n is equal to 4n. So, mangyayari, a sub n is equal to 4n minus 1. But let us try. A sub 1 is equal to 4 times 1 minus 1. So, 4 times 1, that is 4, minus 1, that gives us 3. That's our first term. Let's try again. A sub 2 is equal to 4 times 2 minus 1. 4 times 2 is 8 minus 1. That gives us 7. Is that our second term? Okay, so let's proceed on the third term, where n is equal to 3. So 4 times 3 minus 1. 4 times 3 is 12 minus 1. That gives us 11. So if we're going to observe it, we have the same terms. So our first term is 3. Our second term is 7. And then our third term is 11. So we can now conclude that the pattern in 3, 7, 11 is a sub n is equal to 4n minus 1. So that method is by inspection. So we need to think of a way on how to get the pattern given the terms of a sequence. So I hope that is clear with you. Let's just practice and practice to learn even more. Okay? You can do it. So let's have another one. Let's proceed on our second method, because there are times that it takes time for us to think for the trial and error, okay? What is this second method? It solves algebraically. So we need to form equations. But we need to be careful enough on how to simplify polynomials. So given again the sequence 3, 7, 11 using the second method, take note that the step 1 is always getting the common difference. And let me remind you as well, there are also times that we will not get the first common difference, maybe on the second common difference. If that happens, it gives us a hint that the pattern is a quadratic equation. So that's another way. But let's focus first on having this method. So going back, step 1, get the common difference. You know that already. Am I correct? Do you agree with me? I hope that you master it already. We can now proceed on step 2. So what's our step 2? Step 2 is we need to form 2 equations. Particularly, we need to form 2 linear equations by choosing 2 consecutive terms. So I suggest you always choose the first 2 terms because that is quite smaller for that specific example. But it's always your choice. And we will end up the same result. So we will choose now a sub 1 and a sub 2. That gives us 3 and 7. Okay? So take note of that. A sub 1 is equal to 3 and a sub 2 is equal to 7. And always remember that having the first term, the value of n is 1, and having the second term, the value of n is 2. For the linear equation, this is always the formula. We need to use a sub n is equal to a times n plus b. So a sub n is different from a times n. So be careful on writing your symbols. So let's start with n is equal to 1. We will replace all n by 1. So a sub 1 is equal to a times 1 plus b. Then simplify. We all know that a sub 1 is 3, and then a times 1 is a plus b. So that is our first equation. 3 is equal to a plus b is also similar with a plus b is equal to 3. So that is another property. Then let's have n is equal to 2 because we chose 7. So a sub 2 is equal to a times 2 plus b following the linear equation formula. Then a sub 2 is 7 because that's already given. That's the second term. So we will have a times 2, that is 2a plus b. That gives us the second equation. Is that clear? Okay. So what's our next step? For the step 3, recall your grade 8, which is the elimination method. What does it mean? We need to subtract the 2 equations in order for us to get the missing values. So our goal for this method is to get the values of a and b. So one way is we need to use the elimination method. So I'm going to show you how to use this method. Why did I have equation 2 first? Because it has a greater value. For you not to be confused on having negatives. So again, step 3, subtract equation 2 and equation 1. That is elimination method. This is to get the values of a and b. So let's write first the equation 2. So that is good. 2a plus b is equal to 7. And then the equation 1 is a plus b is equal to 3. So we're going to subtract 2a minus a Very good. That is A. Then B minus B. That is 0. We don't need to write it. Then 7 minus 3. The answer is 4. Very good. Then we're not yet done because we also need to get the value of B. So you're just going to choose either of the two equations. For me, I'm going to choose equation number 1. So that is, again, A plus B is equal to 3. So we need to substitute the value of A, which is 4. 4 plus B is equal to 3. So we need to combine the like terms. So the like terms there are 4 and 3. So in short way, we're going to transfer 4 beside 3, having a positive 4. It will become a negative 4 because we transfer it to the other side of the equation. That gives us negative 1. So take note that the value of A is 4 and that the value of B is negative 1. Okay? So we will now proceed on our last step. So our step 4 is we're going to substitute the values of A and B to our formula in linear equation. Again, that is A sub n is equal to an plus b. So let's start with the linear equation formula, which is A sub n is equal to an plus b. So A sub n is equal to an plus b. Write it properly. A sub n is different from A times n. So A sub n will still become A sub n is equal to A will become 4 because that is the value that we get. And then B is negative 1. Then as you can notice, we can still simplify. So we will get A sub n is equal to 4n minus 1, which is similar to what we get a while ago. So I will not insist any method. Choose whatever you want that will make your life easier in solving this kind of problem. Okay? So there are times that we don't need to do those things because sometimes the pattern is obvious. So having this second example, determine the general pattern of 5, 10, 15, 20, and 25. So I think that's very easy. What is the pattern on this sequence? Okay, so maybe some of you will tell to me that that is by 5. So in a higher form, that is correct. Very good. The sequence shows multiples of 5. Or simply as 5 times 1, which is 5, 5 times 2, which is 10, 5 times 3 is 15, and so on. So with that gives us a general pattern, which is A sub n is equal to 5n. Okay? Is that clear? Okay, let's proceed to another example. What if we have 1/2, 1/4, 1/8, 1/16? Okay? So, again, let's think of the pattern behind the sequence. Kindly look what is obvious. Okay, as you can notice, all the numerators are the same. This gives us a hint that the general pattern has also 1 in the numerator. Okay, so take note of that. So let's now focus on the denominator. Having the values of 2, 4, 8, and 16. What do you think? Why is it that 2 became 4, then 4 became 8, and then 8 became 16? You have any idea? Okay, thank you so much. Very good. The denominator shows the values of powers of 2. What does it mean? We have exponents. wherein the base is 2. So 2 raised to 1, that is 2. 2 raised to 2, that is 4. 2 raised to 3, that is 2 times 2 times 2, that gives us 8. And then 2 raised to 4, that is 16, which gives us a general pattern of a sub n is equal to 1 over 2 raised to n. Okay? I hope all the illustrations are clear with you. If you have further questions, you can have a communication with your teacher. Okay? So thank you so much and have a nice day.